Okay, so we're kind of going back to 12.7 again because we ignored the fact that there is an ambiguous case with the law of sines. And that will be seen in 12.7, just a couple of problems, and then again in 12.8 when you're just solving general triangles and you have to know, do I use the law of sines? Do I use the law of cosines? Is it an ambiguous case? What do I do if it is? So what does it mean to be an ambiguous case? Well, if you go back to your geometry days, remember we could prove two triangles were congruent if the side, and the angle in between the two sides were congruent, or if the three sides of two different triangles were congruent, or if the angle and the side, two angles and the side in between them of two triangles were congruent. And then there were other scenarios where you could definitely not prove that two triangles were congruent because they might be different sizes. That was an AA scenario, because if you think about it, an equilateral triangle, those are all 60 degrees, and I can make that any size I want, right? So their sides are proportional, but they are not congruent to each other. So an AA, angle, did not prove triangles were congruent. Another scenario was the SSA. So looking down here, if I gave you a side length of B, let's say this is 12, side length of A, which is 10, and I gave you this angle right here of 20 degrees. So B is the same as this B, 10 is the same here, and this angle is the same here and here. So what, are these two triangles, ABC and ABC, congruent to each other? No, because side, angle was given. Side, angle was given. And what happens is you spin this side in with your protractor, your compass, and you can create a different triangle in there. So this 10 stays the same by swinging the other direction, so it should be swinging a little bit further than that. So you have two different scenarios. So side, angle does not mean that two triangles are congruent. Therefore, if you are given information that's in that form, side, angle, you might have two different solutions to the problem. You could have no solution to the problem, or you could have one solution to the problem. You are now going to have to figure that out. Okay, how do we figure that out? So, how do we conduct the ambiguous case? Well, I tried to make it a little easier by calling it the BA test. So yes, that's why there's a sheep up here. So what does BA stand for? Well, B is one of the sides adjacent to the given angle, so that's letter B right here. So if you might always refer to the given angle as angle A, and then make B and C, you have the adjacent angle that's given to the given side length that's adjacent to the angle. You have A is the opposite, right? 10 is the opposite side. It's opposite side of the given angle. And then the height, so these dotted lines up here are representing the height of the triangle. Right, so what is the height? It's the perpendicular from letter C down to side AB. So how would you calculate the height? Well, think of it as right triangle trigonometry, right? So sine of 20 degrees equals the height divided by the hypotenuse. Well, the hypotenuse is B. This is my height, H. So how do I find height? I would just multiply B times sine of the given angle, and that equals my height. So that's how I'm getting that information there. So then, once you calculate your BA, or once you see the BA test, you find BA, and then you move to either number 2 or number 3 based on the given scenario. So the only thing you're looking at is the given angle acute? Is it less than 90 degrees? Or is the given angle obtuse? Is it greater than or equal to 90 degrees? If it's acute, this is when you have your ambiguous case scenario. And your ambiguous case leads to two solutions. Otherwise, you might have a no solution or one solution. If it's obtuse, the only thing you're checking is to see if it's a one solution or a no solution. There's no ambiguous case for an obtuse angle, an obtuse given angle. Okay, well, let's try to sketch out why this is. So right here, I'm going to try to sketch out that scenario up here. So it says so we were calling this A, we're calling this B. It says if length of side B, so that's going to be this, is longer than length of side A. So this is side A, this is side B. And A is greater than the height. So remember, this is the height right here. Then I'm going to have two solutions. That's the scenario I drew up here. B is longer than A. And so what do? And A is longer than H. So that means it can swing in and out right here. So your side length C changes. I have it out here, and then I swing it in, so my side length of C can either be this length, or it can be the entire length. So that's why I have two solutions. Okay, let's look at scenario number 2. It says if A, so let's make our A, B, and C. So here's my A, here's my B, here's my C. If A is less than the height, then there's no solution. Well, that should make total sense, right? Here's my B, here's my A. Well, if this A is less than my height right here, that means it's floating in space. It's never going to connect to vertex B, which means it's never going to create a triangle. So it's just floating here. The shortest your height can be is A. And if A is shorter than that, that means the triangle doesn't exist, because the perpendicular length is the shortest length from vertex C to side length AB. And then for all other scenarios, it's going to be one solution. So if H does equal A, the height equals A, then that means there's one solution because it's a right triangle, right? And you can try to think of some other scenarios as well. Okay, now, if the angle that was given is greater than 90 degrees, that means my angle A is no longer acute, but it is obtuse right here. And then I say that B is less than A. So this side is less than this side. Then I'm going to have one solution. Okay, that makes sense. B is less than A. This A has to be the longest side. Why does A have to be the longest side? Well, back in geometry, again, you learned that if this is my obtuse angle, and an obtuse angle is greater than 90 degrees, greater than or equal to 90 degrees, or just greater than 90 degrees, actually, otherwise it's a right triangle. So it's greater than 90 degrees. If it's greater than 90 degrees, that means these other two angles have to be less than 90 degrees. And the side opposite the biggest angle, which is this one, must be the longest length. So if A is greater than B, or B is less than A, then there's one solution. But if A is less than or equal to B, then there's no solution, right? That doesn't work. If it's equal to, it's just going to be here over here. It's not going to connect. It needs to be longer than that. If it's less than that, again, you have a scenario where it's just floating here in space. It's not connecting. It must connect because letter B is opposite an acute angle. This is an obtuse angle, so side A must be longer. So I know that's a lot of information to try to take in, but you need to, so what I suggest you do is you pause, you reread through this. You might want to grab your textbook and try to look at the scenarios on page 592 and 593. Oops. Page 592 and 593. Read through that. You could also try to look up another video on YouTube about ambiguous case. That might help you. But just try to absorb it for a few minutes. Try to take it in. So pause the video, try to take it in, and then, without listening, coming back and listening to me, try to do the examples and just see how far you get. Okay? Good luck. Okay, so how did you do on this first example? So first you draw a diagram. So here's my A, here's my B, here's my C. A was the given angle, so this is 40 degrees. 15 is its opposite side. Angle B we're trying to find. Side length 8 is over here. So obviously my diagram is not drawn to scale because I didn't make my 15 super long, so it should be something like that instead. Right, so this is my letter B, we don't know this is my 15. So here we have it, 8, and then 15 is way longer. So I have my B, which is 8, I have my A, which is 15, I have my height. My height is 8 sine 40. So my height in this scenario is equal to 5.14. Well, this is no special case right? So A is definitely longer than the H, so that means the triangle exists. And then, but B isn't longer than my A or my H, so, or sorry, it isn't longer than my A, but it is longer than my H. This just means one solution. So then you just set it up as normal. Sine of B is to side 8, as sine of 40 is to 15. We do our cross multiplication, inverse sine, and you should have gotten 20.05 degrees. Okay, great. So if you got that, very good. You can try another one on your own, pause now, or you can follow along. But if you didn't get it, but now you understand it, then try the next one. Okay, here's example number 2. Again, my diagrams initially are not very good. This is a length of 20. Oops, I just erased it. This is a length of 20, so it's a little bit longer than my 15. But then, so here's my scenario. So A is 15, B is 20. My height is 20 sine 40. Remember, you keep the same information as number 1. We just put a 40-degree angle, side length 15, but 20 changed now to a bigger number. So now we can see that B is greater than A is greater than H, which means I should have 2 solutions for this triangle. Either I have this acute scenario, where the side is like this, or I swing it in, and I have an obtuse angle for B. So B can either be an acute angle, like this first scenario, or angle B could be an obtuse angle. So once you know that, you still just have to set the law of sines up as you would. So sine of 40 is to 15, and sine of B is to 20. You cross multiply 20 over here, you take the inverse sine, you should have gotten that B equals 13.4 degrees. So that's this angle right here. So I try to draw it a little more to scale down here. So this angle is 13.4 degrees. Well, if I'm swinging this side length of 15 in, then that means this side is also going to be a length of 15, which means I have an isosceles triangle right here. And if this is an isosceles triangle, that means these base angles are the same measure. So this is also going to be 13.4. That means my other option for this obtuse triangle option, where the side length is 15, the side length is 20, and angle A is 40, my other option for angle B is the supplement of whatever angle you found, right? Because these two angles are supplementary. So my other option is to take 180 and subtract 13.4, right? So my other option for B is 166.6 degrees. Will it always be the supplement of the first angle that you find? Yes, it will. So if you can, hopefully you understand this isosceles triangle bit and how we're finding the supplement. If you don't, then you're going to know you're going to find one answer, you're going to do the BA test, and then your other answer is the supplement of the first one that you find. And that's it. So pause and try the third one on your own. Okay, draw your diagram. We have a 30-degree angle for A. Side length of A is 4. Side length of B is 10. I know my A is 4, my B is 10, and I find my H by doing 10 times sine of 30. Well, sine of 30 is 1/2. 10 times 1/2 is 5. Well, right there, immediately, I see that H is bigger than A. And if H is bigger than A, my height's taller than my A. That means I have a scenario where that's not connecting. But this is out there in space like that. So therefore, what do I have? No solution. That might have been obvious from the lack of space down here. So there you have it. No solution for this one. So go ahead and work through the next paper on your own, the Solving General Triangles. Look at the details at the beginning. Read when you're going to use law of cosines, when you're going to use law of sines, when there might be an ambiguous case. Try to apply that in each problem. Practice your BA test. Once you complete those 2 pages, then you can go ahead and start on the book work. And if there's another link and you want to check your solutions for the general triangles, then you can do that too. Okay, good luck. I hope you understand. Try the homework. I don't want you to not attempt it, or come see me tomorrow if you have questions about it. We will address it in class. I'll answer your questions, but then we still have another section to do that's new material. Okay, I will see you soon. Bye bye.